All right, welcome back, chemistry fans. We're going to do Unit 9, Topic 3, Part 2. Kind of weird how this is working with the gas laws, but we had to break it up just to make it a little bit easier for you to digest. So the first one was on ideal gas law itself. Now we're doing some of the associated ones, such as Boyle's and Charles' law. So let's jump right into it, and let's practice these two problems dealing with different versions of the gas laws. Now, what I tried to teach you in class is that you always start with PV equals nRT, and then you cross out the letters for ones you don't see. So notice in this first one, I've got volume, which is liters, and I've got pressure, which is one of these weird units. I don't see anything to do with Kelvin, which is the temperature, or moles. So that means I can cross those out. So what I end up with is PV P1 V1 equals P2 V2. So now you always associate the two numbers that are together, but you could read this and it would tell you how to associate it because they say they're increasing the pressure. So that means they are going to change the volume. And that's what we're looking for, is what happens to the new volume if I'm at 60, but we don't know what happens. So we're just going to solve this by dividing both sides by 60. And so I've got 14.3 times 40 divided by 60, and you get the new volume is 9.53, and these are in liters. Okay, so let's do now number 2. And we've got liters here and degrees Celsius. But here's our problem. Celsius cannot be used in these equations. You must add 273 to both of these. So that would be 293 Kelvin for over here. And this one, 250 plus 273 is 523. Okay. So now what we're going to do is we're going to place this into some equation. It's got temperature in it. So if I go back to my ideal gas law, it's got a volume and we see it's got a temperature, but there's no mention of moles or pressure. Now, you could set this equation up with V equals T divided by V equals T, but generally the easier way to do this is V over T equals V over T, and then you apply it ones and twos. The temperature always goes on bottom. So I'm going to associate these together. I've got my first volume of 0.4. I've got my new temperature of 293 after I've converted it. I do not know what the volume will be. It's just another V2, but the new temperature is 523. So what's going to happen is I got to cross multiply. So I've got 523 times 0.4 divided by 293. And what I end up with is a new volume of 0.714, and this is also in liters. So that'd be 714 milliliters. Okay, this is everything I wish to share with you for your homework tonight. Thank you so much. I will talk to you again soon. Bye-bye.